Then you change to the, then is -2. The second, you change to the plus to minus. Then you add 90 degree to here. Then you can easily convert it the plus to minus cylinders. Okay, so I'm going to show you one more time. So first, this is a ferrule, this is cylinder, and this is axis, right? How do we change from the top to the lower? First, you need plus spheral and the cylinder astigmatism, which is -3 and the +1. Then you're getting the -2. Second, you just change this cylinder sign. Keep this power, right? Keep this power. From plus to minus is -1. Then you change the axis. You just add 90 degree here. Then they change from 90 to 180. Then you finish all the process. How do you convert it plus to minus the cylinders? Okay. So I give you 1 minute. Let's change. 1 or 2 minutes. Let's change this. Student, please take out writing a paper or using your cell phone to see if you can get in this number. 2 minutes. 1 eyes, 1 minute. All right. Anybody can have the same? I think, okay, this is the first one. Let's do that together. All right. First, about the spheral, we need plus this power and to this power. So -2 plus 1 is -1, right? Then we change the plus to minus and keep the same power. So this is +1, change to -1. Then 90 degree. This is 180. So this one is same. Plus this 2, this is spheral, change to the plus to minus, keep the same power and add 90 degree. So I don't think this is any problem, all right? So could you change to this one? I give you 2 minutes. Let's practice. After that 2 minutes. Let's see if you do the getting the same result. So far, any questions? Our students have any questions so far? No? Good. So this purpose, we need to change to the plus cylinder to minus cylinder. 2 minutes. 2 minutes. Okay. 2 minutes. Okay. So this is the answer. This is the answer. All right. So very simple. Let's say the first add up plus 4.5, right? Then change to the plus 1.5 to minus 1.5 and 90 degree, then 180. Very simple. Second one, plus minus 3.5, change to -2 and 90 degree. 90 degree is 200. 200 minus 180 is 20 degree. Okay, they are same. So here is 0. When is 0? We don't write 0, okay? Because in our length, there was no 0 length. We just to the plane length. PL means plane length, PL, all right? You give it a glasses, actually just a glasses, no power. We call that plane length. So we don't write 0, we write PL. Then minus 1.5 and add 90, 170. So very simple. Then, as an optometrist, we are talking about how do we corrections, right? So in your left side is a model show the myopia, where the focus in front of the retina. In your right side, they show the hyperopia, where focus behind of the retina. The vision corrections is, remember this word, MPMVA. This is actually a little bit stupid. Just remember what you like, right? This is called maximum plus for the maximum visual acuity. That means we give our patients the maximum vision acuity. That is the best correction for your patients. All right. So let's say if the spheral lens, that means all the power meridians, they have the similar power. However, in our the illuminations, we don't draw the all power. We just plus. Normally we writing the 1, 2, 3, 4. This is more complicated, so therefore we making even simple, making it just two directions in the future. So this is spheral lens. Spheral lens. They have four directions, right? We don't say everywhere. They showed everywhere. This is a four direction: top, lower, left, right. They all have -2. However, if the patients have the spheral and the cylinder lens, they have the different power. That where is astigmatism. So we need to show that. For example, like here, horizontal, they have -2. In the vertical, which is red, they have more strong power, right? They have -3. So they have different power in the astigmatism. So how do we understand this? So the spheral, which is myopia and hyperopia, is easy to understand, right? We're using the lens, which is have the same power in all directions. However, in the astigmatism, especially, normally they have the different axes. So how do we understand their axis and the power? So here is the normal lens. We are going to understand axis and the power meridians. Let's see this left side first. So in this left side, where is the power? In this lens, because they are focused here. Their power meridian is here. This is power meridian, right? All the light coming from this side, you can see this through this lens, they focus here. So this is the power meridians. If you vertical that, you can see the power meridians is here. So where is the axial meridian? Axial is actually the vertical to the power. Vertical to the power. All right. Here is the purple. They also here. Then this after the light coming to this lens, they focus on the green part, which is focus line. So this is how do you understand when we giving the astigmatism, we need to think about power meridian and the axis meridian. Actually, the power meridian and the axis meridian, they are vertical. They are perpendicular to each other. So this is the real lens. This is the basic item when we giving the prescription and they make this kind of lens to corrections the different axes. This is a lens. And this is the concave lens for the myopia. So let's think about spherical refraction error. Think about if a patient, this have a very strong power. If the normal patient we think about, assume is 60 diopter. This patient have 62.5 power. All right. So therefore, his power will be the myopia because they have so strong power. This is 60. After that, they will focus in front of the retina. So this is minus 2.5. If we give minus 2.5, they can refocus on the retina. About the hyperopia patients, they have less power, only 56. What happened? This is hyperopia. They focus after the retina. Therefore, we need to give +4, making them refocus on the retina. All right. So this is how the spheral refraction error. Very simple. Very simple. So how about astigmatism? Astigmatism, there was in means in the different, the power that different. So we still remember from 0 to 30, 150 to 180. If the axis is here, we call with the rule, right? From 60 to 90, from 90 to 120, we call that against the rule. Between the 30 to 60, 150 to 120, we call that oblique. All right. So this is they have the different axes. So let's see these patients, if they all have -3, if they have -2 in the 180, so this is with the rule. 90 is against the rule. 135, which is oblique. So they have the power in the different axes. So the question is, how do you understand? How do you read your prescriptions? Let's see this case. This is the red part is spheral is -1 is myopia. However, they have -2 degree, but the axis is 180. Right? 180 is called axis meridian 180. where is the power meridian? Is 90, which is perpendicular to that. So let's see this slide. If you still remember here, if the axis meridian is 180, where's the power? Power is right here, right? It's vertical. The same. If the axial meridian is vertical, his power is horizontal, which is perpendicular to the axial meridians. So this part is axial meridian 180, his power is 90. So first we draw its cross. -1, which has means all the direction. Actually, we can write in here, but in the you'll understand. We don't need to write in the 4 direction. We just need to write in 2 directions, right? Horizontal and the vertical, right? They have -1. So because this patient has axial is 180, where is the power? Is perpendicular, which is 90 degree. So his power is 90 degree, right? So we should draw here. So add them up. This one will change to in the horizontal, they have power 0.1, but in the 90 degrees, they have a power is -3. So this one you can see when you give the prescription to these patients, they have different power in the different axis or meridians. So I give you 1 minute to think about this because some students need to, sometimes they mixed here. So look at these figures, think about to see if you can understand that. 1 minute.